Okie doke, so average rates and instantaneous rates. So suppose that a quantity Q is given as a function of time. So that is, if we were to graph something like, I don't know, this, okay, and we're going to call that graph, y is equal to some function, okay. If we look at two specific points, okay, so let's say at t time 1 and time 2, okay? And what we're going to say is that, if we substitute those values in, we're going to get some value for our function here, as well as some value for our function here as well. Okay, so if we substitute those values in, we get some value back out. Okay, so if we want to look at the average rate of change between those 2 points, basically we're going to draw a chord between these two and look at what the gradient is of that chord. Okay, and whatever the gradient is of that chord, it's going to give us the average rate of change between the 2 times. So to formalize this, average rate of change is equal to, and it's just the gradient formula, so in this case it's Q2 minus Q1 over T2 minus T1, okay? And whatever this is, it will give you the average rate of change. Now, let's say that we wanted to work out what the instantaneous rate of change corresponds to. So that is what the instantaneous rate is at a particular point on this graph. Okay, so to do so, what we're going to do is we're going to find the value of the derivative at that point. Okay, so for the instantaneous rate of change, we're going to be looking at dq dt at whatever the value is that we want. Okay. So when we talk about a rate of change, particularly in this mathematics course, we are referring to the instantaneous rate of change. So whenever we say rate of change, we're talking about instantaneous rate of change. Okay, so let's have a look at an example of this. So the number of bacteria in a culture according to the function b is equal to 2t to the power 4 minus t squared plus 2000, where t is time in hours, find the number of bacteria initially. Part B is the average rate of change of the number of bacteria between 2 and 3 hours, the number of bacteria after 5 hours, and then finally the rate at which the number of bacteria is increasing at 5 hours. So let's start off with the first bit. Now, to do the number of bacteria initially, so B is equal to 2t to the power 4 minus t squared plus 2000, and we're looking when t is equal to 0. Okay, so in other words, our initial time is when no time has passed, so when t is equal to 0. So we're going to substitute that into our equation here. So 2 lots of 0 to the power 4 minus 0 squared plus 2000. Okay, put it into a calculator or just do it in your head, and we get 2000. So there is initially 2000 bacteria. Okay, so pretty straightforward. It's just a simple substitution, and just knowing that initially means that when no time has passed, or when time is equal to 0. Okay, so the second part is the average rate of change between a number between 2 and 3. So we're going to be looking at when t is equal to 2 and when t is equal to 3. I'm just going to spread that out a little bit. Okay, so when t is equal to 2, we're going to substitute it into the equation again. So we're going to get 2 lots of 2 to the power 4 minus 2 squared plus 2000. Okay, and we'll put that one straight into a calculator. So 2 lots of 2 to the 4. Bloody hell. 2 to the... Oh, for God's sakes. Why can't I seem to do this? 2 to the 4. There we go. Minus 2 squared plus 2000. Okay. And so we get 2028. Okay, so it's not growing at an amazing rate, but we will have a look and see after the third hour, how much it does in that one. So I'm going to do the same thing. Okay, so our B is 2 at 3 hours, so we're going to substitute the 3 in, minus 3 squared plus 2,000. I should put those in brackets because it's identifying that that's the value we're substituting in. So 2 lots of 3 to the power of 4 minus 3 squared plus 2,000. That's 2,153. Now, to work out the average rate, we're going to use our formula. So the average rate of change. Okay, so this time it's just going to be the change in the bacteria. So 2,153 minus 2,028 over the change in the time. So between the 3 and the 2 hours, so it is only 1 hour there. Okay, so we can put it into the formula like that, and we can substitute these in, and then we can put this into our calculator to get that the average rate of change is equal to 125. So the average change of rate, or rate of change, sorry, is between the second and third hour is 125. So the increase in that first, or that second, I guess, hour is 125. Okay, let's have a look at question part C. And that is the number of bacteria after 5 hours, okay? So the number of bacteria after 5 hours, so at T is equal to 5, we're going to substitute that back into our equation. So that's 2 lots of 5 to the power of 4 minus 5 squared plus 2,000. Okay, and once we've done this, we can substitute it into our calculator again to get 2 lots of 4 to the power of 4, 2 lots of 5 to the power of 4 minus 5 squared plus 2,000. Okay, and that's going to give us that the amount of bacteria after the 5th hour is 3,225. Okay, now our last question is then to find the rate at which the number of bacteria is increasing after 5 hours, okay? So we're looking for the instantaneous rate at 5 hours in this case, okay? So we're going to start off by finding the derivative. So if we start off with our B value, I'll put in our initial function, okay, just so we know what we're working with. We've got 2t to the power of 4 minus t squared plus 2,000. Now, when we differentiate this one, we're differentiating b with respect to t, the time. Okay, so to b dt is equal to, now differentiating this, the 4 comes down the front, we get 4 times 2, which is 8. So 8t cubed minus 2t, and then that last term, that constant term, disappears. Okay, so we're looking for the rate after the 5th hour. So at t is equal to 5, dB dt is equal to 8 lots of 5 cubed minus 2 lots of 5. Okay, and we're going to substitute this one in. So we get 8 lots of 5 cubed minus minus 2 lots of 5. So 2 lots of 5, and this constant term is not here anymore. Okay, so just popping that into derivative, and we get that at t is equal to 5, the rate at which the function, or the bacteria in this case, is increasing is 990 bacteria, and that'd be per hour. Okay, so at that particular point, it's 990 bacteria per hour. Okay, so that's it. That's how we can calculate our average and our instantaneous rates of change.